Alright, this video we are looking at the area of a plane region. So for this example we used 5 rectangles. We've got 2 different ways we're going to do it. We're going to find 2 different approximations of the area, the region lying between the graph of negative x squared plus 5 and the x-axis, and between x equals 0 and x equals 2. So we're looking at doing both an inscribed set of rectangles, notice these are all inside, and we're doing a circumscribed set of rectangles. All of those are being on the outside. So let's start by looking at our divisions here. So we can see that each one of these widths is 2/5. So that's 2/5, that's 2/5, that's 2/5. It looks like a 7. 2/5, 2/5, right? So I know my base, right? Because we're looking at the area of a rectangle, which is length times width, or base times height. So in this case, our base is all 3/5. Our heights are the things that are changing. And notice that our height always corresponds to the rightmost point in that interval. So here, this value is f of 2/5. This value is f of 4/5, f of 6/5, f of 8/5, and lastly f of 10/5, or f of 2. Now that's for the inscribed. For the circumscribed, the point is always the leftmost point. So this is f of 0, which is just 5. You can see that. This one is f of 2/5. This one is f of 4/5, f of 6/5, and lastly f of 8/5. So notice they both have 5 heights, but where we start is depending on whether we're circumscribed or inscribed. So let's start by taking a look at the inscribed triangle, so from the rightmost point. So we're going to be looking at this one, okay? So we know our function is negative x squared plus 5, right? So f of x equals negative x squared plus 5. We know that our area is just going to be the sum of all of these f of xi times 2/5 from I equals 1, 2, 1, 2, 3, 4, 5, right? So this is x1, x2, x3, x4, and x5. So we plug in these values, so we get 2/5 times, so we're going to sum all of the f ofs, right? F of 2/5 plus f of 4/5 plus f of 6/5 plus f of 8/5 plus f of 2, right? Or 10/5 if you want to. So we're going to plug each one of these into the function. So we're going to get 2/5 times negative 2/3 squared plus 5 plus negative 4. I don't know why that's 2/3, it's 2/5, sorry. 4/5 squared, so since it's plus negative, I'm just going to say minus, plus 5, minus 6/5 squared plus 5, minus 8/5 squared plus 5, minus 10/5 squared plus 5. So I've got 5, 10, 15, 20, 25. So I've got 2/5 times 25, and then minus, this is going to be 4/25, minus 16/25, minus 36/25, minus 64/25, minus 100/25. So we're going to get a calculator out. So 25 would actually, this would be, we could rewrite this as 625/25, right? By getting a common denominator, multiply the top and the bottom by 25. So we wind up with 625 minus 4 minus 16 minus 36 minus 64 minus 100 gives us 2/5 times 405 over 25. So 405 is divided by 5 81 times. So 81 times 2 is 162 over 25, which gives us 162 over 25. No, it's not approximate, it's exactly 6.48. So that tells us that the area of the inscribed triangle is 6.48 square units. Okay? So now that we've done that, what we want to do is we're going to look at the circumscribed. So we're going to look at this value, this value, this value, this value, this value. So it's still the same formula, only this is now x1, x2, x3, x4, and x5. So we're still doing I equals 1 to n of f of xi times 2/5, but in this case it'll just be, we can pull the 2/5 out and then sum all of the fxi's. So f of 0 plus f of 2/5 plus f of 4/5 plus f of 6/5 plus f of 8/5. Alright, so we're looking at, once again, we know that this is negative x squared plus 5. Or we can put it as f of x, right? So, when we plug these in, we get 2/5 times f of 0 is just 5, plus f of 2/5, so that's going to be minus 2/5 squared plus 5 minus 4/5 squared plus 5 minus 6/5 squared plus 5 minus 8/5 squared plus 5. Use a bracket since that's what I had. So it's still going to be 2/5. We've got 5 plus 5 plus 5 plus 5 plus 5. 5, 10, 15, 20, 25 again. Minus 4/25 minus 16/25 minus 36/25 minus 64/25. Once again, we can change this to 625 over 25, and then we do 625 minus 4 minus 16 minus 36 minus 64. We get 505. So 2/5 times 505 over 25. 5 will go into 505, 101. That's 202 over 25. Which gives us 8.08. So what this means is, we know that if 6.48 is the area of the inscribed rectangles and 8.08 is the area of the circumscribed rectangles, then the area of that region has to lie somewhere between those two values. So if you have any questions about computing the area of a solid, a plane region, just shoot me a reminder or ask a question in class.